Okay, so this is the video that covers the giant chunk of application problems in the homework. I'm gonna try to, give you various examples. I think we cover the main things here, but of course, feel free to ask questions if you come across a homework problem that is just way too different from these examples. All right. Application problems are all about applying what you know to solve real world problems. So let's get it. The correlation between math and other stuff. So what do we know about f prime of a? F prime, the derivative of f, the slope of f, the rate of change of f at x equals a. And specifically, we'll talk more about rates of change in the next video, 1.8. All right. Goodness. All right. So this is approximating things. All right. So specifically, the derivative is used to find marginal cost. All right. Marginal cost, remember, is just how much does it cost to make one more thing. All right. If we have a cost function where the variable is the units produced. So let's say we're, producing 100 units, then f prime of 100 would be the marginal cost at 100 units. It would be the cost of producing one more unit if we're already making 100. What's the extra cost? What's the added cost? All right. We're going to be using these derivatives to approximate some other stuff as well. You might say, what other stuff, Jason? Stay tuned and find out. Here we go. All right, so look at an example. Example number, I lost count, 5. All right, and this says at the end of the holiday season, so January, sales are expected to fall. You might say, aren't they expected to winter because it's January? No, they're expected to fall. Anyway, on January Xth, sales are roughly the following, and we'll switch over to write this down. All right, so on January X, sales are roughly given by the function S of X equals 3 plus 9, that's a 9, divided by X plus 1 squared. So on January 1st, the sales are what happens when we plug in 1, okay? And this is given in thousands of dollars. Thousands of dollars. All right, and what we are going to do is compute S of 2 and S prime of 2 and interpret. All right, so find S of 2, we'll plug in 2 into our function S. To find S prime of 2, we'll plug in 2 into our function S prime. We don't have the function S prime yet. We're gonna have to take the derivative to calculate S prime. All right, so a couple steps here. So first off is S of 2. Let's plug in 2 into this function. We get 3 plus 9 divided by 2 plus 1 squared. And that should simplify out to, let's see, this is 3. 3 squared is 9. 9 over 9 is 1. Should simplify to 4. And be very careful. So S of 2 is 4. That doesn't mean we're making $4. Right? In thousands of dollars. Okay, so the sales on January X, here X is 2, right? That's what X means, the day of January. So on January 2nd, there's some weird things going on with my pencil today. So on January 2nd, sales are 4,000 big ones. And that's the first part of our answer here. Computed S of 2 and interpreted it. Now we're going to compute the derivative and interpret that. Derivative is the rate of change. So if this function says that sales are $4,000, the derivative is going to be how those sales are changing. All right. And sales are expected to fall. So we should expect a negative slope. Negative slope means going down. Oh, I have it mirrored today. Nice. Going down. In class, I have to do it the other way. Here, my camera's mirrored. That's what we're expecting. So we have to find the derivative. Let's go ahead and copy this real quick and copy this function and then find the derivative. So again, s of x was 3 plus 9 over x plus 1 squared. And now we need to find the derivative. Well, the derivative of 3, that's easy, 0. Derivative of a constant is 0. For the second part, remember, this can be written as 9 times x plus 1 to the negative second. Negative exponents mean reciprocal, so these are the same two things. And the second one is much easier to use the power rule on. So we're going to do that. Power rule says bring down the negative 2, brings us to negative 18. Inside stays the same. Subtract 1 from the exponent and multiply by the derivative of the inside. And the derivative of the inside is the derivative of x plus 1. The slope of the line x plus 1 is just 1. Okay, so let's go ahead and simplify this and plug in 2. So this is going to be negative 18 divided by x plus 1 cubed. And the book asks us to find s prime of 2. So we'll plug in 2 and see what we got. Negative 18 divided by 2 plus 1 cubed. That's going to be negative 18 over 3 cubed. 3 cubed is 27. So negative 18 over 27. Use a calculator for this. It's going to be negative 2/3. Now be very careful with the units here. All right. S was in thousands of dollars. I drew an arrow. You can't see it though. S is in thousands of dollars. Okay. What's our unit of time? For rate of change, right? It should be the unit of S. So thousands of dollars. Let's just start there. Whoa, that's not it. Oh, and I can't undo it. So our answer should be this many $1,000. And then it should be per something. Rate of change. You know, am I $1,000 per day, $1,000 per month, $1,000 per hour? What's our unit of time? We have to go back here and find the unit of time. X is the unit of time, and it's days. January 1st, January 2nd. It's going to be days here. And I did the same thing again. Well, everything's going to be circled in the notes later on. So $1,000 per day. So this is not a very good way to express our answer though, because remember this right here is a rate of change when x is 2. So when x is 2, right, that means on January 2nd, sales are falling. And remember, we know that they're falling because our slope is negative. Negative slope means going down. Positive slope would be going up. All right, remember, think about the person on the bike. You're on a bike here, you're going to be falling, you're going to be going downhill, and that's a very steep downhill. So they're falling by 2/3 of 1,000. Nobody is going to say 2/3 of 1,000. So let's just approximate this. It's going to be falling by about $667. I did it again. Oh no. All right. This is a learning experience for me. I forgot how to do these notes. It's falling by $667. Or if you really wanted to, you could do $666.66. Let's do it. 67 cents, we'll round, per day. So we know two things here, right? Combining our two answers. On January 2nd, our sales are $4,000. But for every day that passes, those sales are going to drop by about $600. All right. That's kind of what's going on here. Graphically, what's going on, if you're curious about the graphical interpretation, is we do have a graph. It's like a vertically shifted reciprocal function. So it kind of looks like this. Do we have that spike from the holiday season that's over here? And then let's say we're right here in January 2nd. These are our current sales and they are falling. But eventually, right, they're going to be falling slower and slower. The Y value here is our answer from the first part, $4,000. The slope, which again, the slope here is negative. That's our answer for the second part. And eventually, they'll kind of stabilize to what they are outside of the holiday season. And that's what the asymptote is in this situation. All right. Let's do one more example just for good measure. All right. Example 6. Suppose the cost, we'll look at a cost function again. Suppose the cost of producing X items is given by this cost function. C of X equals 0.005 X cubed minus 0.5 X squared plus 28X plus 300. So suppose we have this cost function, and I'm going to ask you some things about this. But real quick, remember that the cost function is the cost of producing X units. All right. So we talked about this a while back, but that's supposed to be a 300. So this right here, these are the costs that are directly related to how much we're producing. But this 300 right here, it doesn't matter how many units we're producing, we always have to pay that 300. Remember that this is what we called fixed costs, costs that are unrelated to our production value. So it could be like, like the cost of rent for whatever, establishment you have, the other things. I'm going to keep on going. All right. So we have some questions to ask about this. And part A is going to be, what is the extra cost of increasing production from 50 items to 51 items? All right. So we're just going to find how much does it cost to make 50 items, how much does it cost to make 51 items, and we're just going to subtract the difference, and that's going to show us the extra cost of that 51st item. Okay, so we'll just go over here and evaluate. All right, we need C of 51, we need C of 50, and then we'll just subtract them. So go off to the side, plug this into a calculator when X is 51. Plug the same thing into the calculator when X is 50, and you should get the answer. All right. So I actually don't remember the answer, so I'm going to go grab my calculator and plug it in right now. 51 cubed minus 0.5 times 51 squared plus 28 times 51 plus 300. So to produce 51 units, it's going to cost 1,000. Oh, I see what happened. It's going to cost $1,090.76. And for 50 items, we'll just replace the calculator, 51 with 50. We're going to get $1,075. Exactly. No sense. All right. So the additional cost is just that difference, which is going to be the $15.76, I believe. So we say that's the marginal cost at this production level. I spoiled it. That's the additional cost of increasing production from 50 units to 51 units. And on a completely unrelated note, let's look at part B. Part B, which is blue for some reason. Part B asks, what is the marginal cost? What is the marginal cost when x equals 50? So remember that marginal cost is just going to be the derivative of the cost function. And when x is 50, we'll plug in 50. That's what marginal cost means. All right, so what we're going to do over here is we're going to find c prime of x and plug in 50. So we plug c prime of x is going to, we'll use the power rule again, 0.015 x squared minus 1, let's not write the 1, x plus 28. Let's plug 50 into that. C prime at 50. You can pause the video, plug it in at home. Make sure your calculator work is on point, especially good practice to use the calculator that we use for the quizzes for the online calculator. And 0.15 times 50 squared minus 50 plus 28. And it's entirely possible I will make some calculator errors during these videos as well. Feel free to always ask about that if you'd like. You get 15.5 is what c prime of x is. So again, we need the right units, right? So the additional cost was $15.76. And the marginal cost is going to be $15.50. So very, very close, right? And really, they're kind of the same thing. One is just an approximation of the other, all right? So the marginal cost is $15.50 per additional unit. And over here, the extra cost we found was exactly $15.76. So they should be very, very close. All right, so one final comment on this video before we move on is that basically in economics, and as far as this class is concerned, derivative is going to be the same thing as marginal. So marginal cost is the derivative of the cost function. So marginal revenue is what you might think. Going to be the derivative of our revenue function. Marginal profit, you guessed it. Marginal profit is going to be the derivative of our profit function. So watch out for that. You can have this a definition. Watch out for that in the homework. There are some problems that deal with these terms as well. Okay. So again, marginal revenue would be how much extra revenue do we get for producing one more unit at our production level. Marginal profit would be how much more profit do we get by producing one more unit at our current revenue, or I said our current revenue level, at our current production level. Okay. So you'll see these in other homework assignments. Hopefully this video at least gets you started on those applications, and feel free to reach out for assistance or help or questions if you have them. Have a great day.